Dear students, this is our 13th lecture on medicinal chemistry and second lecture on antipyretic drugs. Under the antipyretic drugs, today we will discuss what are anti-gout agents. Now, gout is basically a metabolic disease in which the concentration of plasma urate in the body increases, and this condition is called as hyperuricemia. In the body, normal rate of urate means uric acid is from 1 to 4 milligrams per dl, and if its concentration increases from this amount, then the disease is found in the body, mainly in the joints, which is called as gout. And the drugs which are used to treat gout, they are called as anti-gout agents or anti-gout drugs. Now basically what happens is that uric acid, which is product of purine metabolism, and this take place at low pH, that is under acidic conditions. The water solubility of uric acid is low, and because of that, when the concentration of uric acid increases in blood, it gets precipitated and deposited in joints, kidneys, and cutaneous tissues, and this formation of a built-up of uric acid is called as toffee. And this deposition of uric acid is generally found in the joints, and sometimes in kidney and cutaneous tissue also. And because of this deposition of uric acid, the joints become inflamed, that is, inflammation is there in the joints, and there is a lot of pain because of this inflammation in the body, at the level of various joints in our hands or in our feet. So all kind of joints, they will be found inflamed because of the deposition of this uric acid. Now, different types of anti-gout agents or anti-gout drugs, they are used, but each category of these drugs, they follow a different mechanism, depending upon the type of action they take place. For example, if we are using allopurinol as the anti-gout drug, this will act as by inhibiting uric acid synthesis. So this anti-gout agent will help us to inhibit the synthesis of uric acid in the body, so thereby the concentration of the uric acid in the body will be lowered for some time, and this will help in removing the inflammation of the joints because of the presence of uric acid. Then second category is that some anti-gout drugs, they may increase the uric acid excretion from the body. So when there is increased uric acid excretion from the body, that means concentration of the uric acid will also be maintained. And the two drugs which are mainly used, they are Probenecid and Sulfinpyrazone. They are again organic compounds which are synthesized in the laboratory. Then third category is that these types of agents, they may act by inhibiting leukocyte migration towards the joint. So the uric acid is taken to various joints by the leukocytes. If the migration of the leukocyte is inhibited, Because of that, also the concentration of uric acid will be maintained in the joints. So the commonly used anti-gout agent undertaking this type of mechanism is colchicine. Then, as I've told you, that joints they become inflamed. Inflammation is there in the joints, and we can give general non-steroidal anti-inflammatory drugs also, which will provide the general NSAID action, and commonly used NSAIDs for these types of inhibition of inflammation. They are glucocorticoids. So these are this is again an inflamed finger of a hand, which is responsible for the toffee due to the increased concentration of uric acid built up, which is called as toffee. Now, the anti-gout drugs they are given under two conditions because gout is classified as acute gout or chronic gout. Chronic gout is also called as hyperuricemia. So acute gout is a painful condition that will affect only one joint. So either it will take place say in our feet, or it will take place in our hands, or means that only one joint will be affected by such type of inflammation. And the commonly used drugs for acute gout is NSAIDs, colchicine, and glucocorticoids. Whereas for the purpose of chronic gout is that it will happen again and again. So it will show repeated episodes of pain and inflammation. So it will happen for 15 days, say pain and inflammation, then it will subside, then it will again happen. So repeated episodes of pain and inflammation will be there because of this condition. More than one joint may be affected, and the commonly used drugs for such type of condition, that is hyperuricemia, the Probenecid, Sulfinpyrazone, allopurinol, these are the three commonly used anti-gout drugs which are there for chronic gout type of condition. You can see the sulfinpyrazone is having this type of pyrazone ring, whereas probenecid is a sulfonamide based drug, whereas this is a purine type of compound. Now, the synthesis of some of the common anti-gout drugs we can discuss. First is most commonly used is allopurinol, and this is marketed as lopurine or xyloprim, and its IUPAC name is 1H-pyrazole 34 primidine-4-ol, and this is having this structure. This is basically a purine analog and structural isomer of hypoxanthine, because hypoxanthine is a naturally occurring purine in the body. This allopurinol is an inhibitor of enzyme xanthine oxidase. When this will inhibit the xanthine oxidase, this will inhibit the formation of uric acid basically, because xanthine oxidase is responsible for the oxidation of hypoxanthine to xanthine and subsequently to uric acid. So that means we can say in the body formation of uric acid is being done or being catalyzed by this enzyme, that is xanthine oxidase. And the allopurinol, what it will do, it will inhibit the activity of xanthine oxidase. So it will interact with the active sites of the xanthine oxidase enzyme, and the active site which is responsible for the oxidation of hypoxanthine to xanthine and subsequently to uric acid, that will be inhibited, and because of that there will be no formation of uric acid. So this is how this drug, that is allopurinol, act in the body by inhibiting the formation of uric acid indirectly through inhibiting the activity of xanthine oxidase. Now, the synthesis of allopurinol is very simple. The starting material is hydrazine and ethoxymethylene melanonitrile. So this is ethoxymethylene melanonitrile. When this is condensed with hydrazine in the presence of propane-1-ol as a solvent, this will lead to the formation of this type of heterocyclic compound, that is 3-amino 4-cyanopyrazole will be formed by first nucleophilic attack of this on this compound, and then condensation leading to removal of water, and cyclization will give us this type of pyrazole derivative. And this pyrazole derivative, when reacted with sulfuric acid, this undergoes hydrolysis of the cyano group. So this cyano group will be converted into an amide functional group when this is reacted with sulfuric acid, and then this this amido pyrazole derivative will react with formamide to give us allopurinol through this mechanism. So the first nucleophilic attack of this on the electrophilic carbon of the formamide will take place, and ultimately this amino group will condense with this keto group to form this carbon nitrogen double bond over here, and then this amide nitrogen will act as a nucleophile and H from here, and NH2 ammonia will be removed, cyclization will take place, and then ketoenol tautomerism will lead to the formation of allopurinol. So this is how simple addition condensation reaction of melanonitrile derivative with hydrazine will lead to the formation of allopurinol. The uses of allopurinol is that it decreases the biosynthesis of uric acid, as I have already told you. Therefore, this is used to reduce hyperuricemia in gout. So this is preferred drug in the treatment of tophaceous gout, that where tophi is being formed, then that type of gout is treated with this drug. And this is also used in management of recurrent calcium oxalate kidney stones. So some kidney stones which are formed because of the formation of calcium oxalate, they are also treated with allopurinol, because this will again inhibit the formation of calcium oxalate in the body. Then second drug is Probenecid. This is Probenecid is also para-dipropyl dithiocarbamic acid phenylformic acid, or 4-dipropyl amino sulfonyl benzoic acid. These are the other names for this drug. This, you can say, is basically a substituted benzene sulfonamide derivative. and this is used in antibiotic therapy also, and as an anti-gout medication also. There are two methods to synthesize probenecid. First method is that this can be synthesized from 4-methylbenzene sulfonic acid. Uh, when 4-methylbenzene sulfonic acid in the first step is oxidized either by potassium permanganate or potassium dichromate, basically what will happen, the methyl group of uh, this methane benzene sulfonic acid will be oxidized to carboxylic acid, and this 4-carboxylic benzene sulfonic acid, when treated with chlorosulfonic acid, this group will be replaced by halogen group. So this will be sulfonic acid will be converted into sulfonyl chloride. So 4-carboxylic benzene sulfonyl chloride will be formed from this reaction. Then when this 4-carboxylic benzene sulfonyl chloride is reacted with N-dipropylamine, N-alkylation will take place. So H from here, Cl from here will be removed. This nitrogen as a nucleophile will attack the sulfur and halogen will be eliminated, and we will get probenecid as the product. So this is how through first method this drug can be synthesized, but this method suffer from a few drawbacks. First is that here a large quantity of organic solvents they are required for the reaction, and the use of organic solvents we know is a serious pollution concern. Then heavy metal recovery and treatment of cost they are also high, because these metal salts they are formed as side products, so recovery of these salts is not cost effective. Therefore then this chlorosulfonic acid transportation, storage and use is also a dangerous proposition for this type of product formation. So these are the few drawbacks of this method. So to overcome some of these drawbacks, this method has been slightly modified. Now instead of using sulfonic acid, we are using 4-methylbenzene sulfonamide, and when this is oxidized, again methyl group will be oxidized to carboxylic acid, and then this is directly reacted with bromopropane or chloropropane in presence of sodium or potassium hydroxide, and we will get probenecid as the product. Then third commonly used anti-gout drug is sulfinpyrazone. Sulfinpyrazone is basically an analog of phenylbutazone, whose synthesis we have already discussed. The IUPAC name is 1,2-diphenyl 4,2-phenyl sulfinyl ethyl 3,5 pyrazolidinone, and this is synthesized from the condensation of hydrazobenzene with 2-phenyl thioethyl malonic ester. So this is the diethyl malonic ester, which is substituted by this 2-phenyl thioethyl group. When you know because of the presence of these two esters, the proton present at this carbon is highly acidic proton, and uh, this will make these ethoxy groups as better leaving groups, and these two nitrogens they will react at these carbons, and cyclic pyrazolidinone will be formed, and then oxidation with hydrogen peroxide and acetic acid will oxidize this sulfide group into sulfone group. So this is how we will get sulfinpyrazone in a very under very mild conditions and an easy method for the synthesis of this drug. These are the references which have been used in preparing this lecture. Thank you very much.